Univariate analysis, as you would already know, is the study of a single variable at one point of time. So, based on the kind of attribute you have, let's say a categorical attribute like gender, which would actually have values of male and female, or a numeric attribute like age, which could have values like 10, 15, or 25. The visualization technique and the statistic measure that you would use to interpret these variables will actually be different based on the kind of variable they are. So when you're actually studying a categorical variable or a categorical attribute, you would use a bar chart coupled with the count measure or a pie chart coupled with the count percentage measure. And this will help you to understand how is the data distributed across the different classes inside that categorical variable. So to simplify this, let's have a visual tour. So assume for simplicity that a bar chart looking like this, we have two values, male and female, and a simple bar chart where we have the values, let's say 40 and 60, indicating the frequency of records distributed across these categories. Also, let's say you have a more comprehensible version using a pie chart. So something as simple as this, we have 40 male and 60 female, and this would be in percentages. Now, this is a simple way to interpret and understand how does the categorical variable look like in the data set. Now, this is very simple because we have only two levels in the category. What about those scenarios when we have fairly more complicated categorical variables? So let's say something like class, let's say it's an abstract variable, which would have levels of A to F. So interpreting that is very difficult using simple numbers. But when you put it in a bar chart, or let's say a pie chart, things become fairly straightforward. Let's say A, B, C, D, E, and so on. Assume that we have several more. We can clearly see that two of them stand out. We have larger number of records in B and D. If you do the same with a pie chart, you can actually see that, let's say, class A or let's say class C have a larger chunk of the pie, and there are several other attributes which have a smaller chunk, let's say D, E, F, and let's say X, Y, Z. We can clearly see that there's an important component over here, and there's an important component over here. So this is how you can use bar charts and pie charts coupled with two simple measures, the count numbers, which is the frequency, and the count percentage, which is absolute percentages of the levels, to understand the depth of the categorical variable. On another note, when you're studying a numeric attribute, you will have two simple visualization techniques that will give you very informative results. The most common one is the box plot. The box plot is the easiest and the most common way to interpret a numeric attribute. So let's say when you're trying to understand something like age of the students, you have 100 students, so you have 100 records, and you're trying to understand how is this data looking like. So box plot in a snapshot gives you access to the minimum, maximum, mean, median, range, and quantile values. So what does these statistics refer to? Minimum, as simple as it sounds, is the minimum value from all the observations, and so is maximum. Maximum is the maximum value of all the observations. Mean is the average, which is the sum of values divided by the number of observations. Median will be the middle value, like the 50th percentile. Range is the difference between the maximum and the minimum, and quantile is a set of cut points that divide a set of data into groups containing equal number of values. So let's look at this using a visual tool. So let's assume that we are trying to understand age of students as an attribute. Now this is a numeric attribute, and using box plot to understand how does it look like. So a simple box plot can be interpreted using a simple figure. This would be the y-axis, and since this is a single attribute, this would be a x-axis. So you don't need anything on the x-axis, but on the y-axis, you would have age. Now these numbers at different points would indicate different values. So this would correspond to the minimum value. This would correspond to the maximum value. This would be the 50th percentile or the median. This would be the 75th percentile or the third quartile, and this would be the 25th percentile or the first quartile. So first quartile, third quartile, median, minimum, and maximum. Now, to understand the average from the box plot, so most plotting libraries under R and Python don't really give you a straightforward way to put the mean also onto the box plot. But using a simple technique, you can actually just fabricate this and get the mean plotted along with the box plot. So let's say in this box plot, the red asterisk mark indicates that is the mean value. So this would be the mean. Now this is how you interpret it. You actually get all these metrics visually explained, and you can actually understand how does the data look like. Let's make this more tangible. Let's say we put across some values across all of these statistical measures. So in the case of age, we say that the minimum value is 18, the maximum value is 30. The 50th percentile or the median value is around 26. 75th percentile is 29. Mean is around 28. 25th percentile is around, let's say, 24. Now looking at this, we get a fair amount of idea about the data. We know that the range is around 12 units, but like the minimum is at 18, the maximum is at 30. And on an average, the age of the student is around 28 years. So we know for sure that there's a high amount of, most of the students are mostly fall in the upper age bracket. We also see a great jump from 18 to 24. We also see a great jump, smaller jump from 24 to 26, and so on. So box plot basically gives you a basic overview of the entire data point in a single snapshot. Now, this is also the most easiest way to understand whether there are outliers. So let's say now this box plot presented over here is a fairly straightforward one. And then let's say we have a structure which looks like this. So we can see that there's a huge gap between the minimum and the 25th percentile. On the same way, let's say if we had something like this, you can see that there's a huge gap between the 75th percentile and the maximum value. So these are areas where you can see there are a lot of outliers. And similarly, the jump between two quartiles can actually help us understand where is the data distributed unevenly. Now, this is one of the easiest and the most commonly used technique to first understand a numeric data set.